17, and this is on page, what, on page 174, number 17. Is that correct? Okay, so on page 174, number 17, let's put it up here. We have a southbound bus left Dalton City at 9 a.m. and a northbound bus traveling at the same average rate left the same terminal at 11 a.m. So if one left at 9 and the other at 11, there's what? How much of a time difference is there in there? 2 hours. And then at 2 p.m., the two buses were at least 352 miles apart. At least 352 miles apart. Find the least possible rate of the southbound bus. Okay? So here is some point at Dalton City in which one bus starts north, and then at the same point the other bus starts south. Is that right? Okay. And what is the one thing that is in common on these two buses, for these two buses? Todd says their rate is, all right, well, their rate is the same, okay? And what then do we want to, it asks, find the least possible rate of the southbound bus. So let's let R be what? The number of miles per hour of what? And what do we want to say about this? And Ken says, what do you think? Of the southbound bus, okay? Of the southbound bus. And what then is our one relationship that we know about distance and rate and time? And what can we write down here? Sally says?
That rate times time is equal to distance.
Rate times time is equal to distance, okay? And of course, from this point, from here up to there, right? And then from here down to here, this total distance must be equal to what? At least, and Ron says,
352.
at least 352. Okay, that's distance. So let's write then a sentence that has to do with what? The distance of the northbound bus, let me use this notation, okay? Plus what? The distance of the southbound bus, and we are told that it must be at least. So how can we interpret the phrase at least? And Todd says greater than or equal to, and in this case it must be what? Barb says 352, the number 352. Okay, now let's then figure out what the distance of the northbound bus is. Well, whatever his rate is, which is R, what is his time? And we are told that the northbound bus leaves the terminal at 11 a.m. Is that right? Okay. And from 11 a.m. to 2 p.m. is how many hours? And Ken says
3 hours.
That's 3 hours. So his rate, which is R, times his time, which is what? 3, is the total distance of the northbound bus. Is that right? And then plus what? The rate of the southbound bus, which is what? What number can we write here? Which is R times his time. And what is the time of the southbound bus? And this is 5. Does everyone agree that it's the number 5? Okay? And hence we have this sentence in which this is greater than or equal to 352. And you look at that and you say, well, that's 8R is greater than or equal to 352. And let's see what, now if we divide both sides by the positive number 8, the sense of the inequality stays the same. 8 divides 352, how many times? 44. Oh, look at that, 44. So then the question asks, find the least possible rate of the southbound bus. The least possible rate of the southbound bus. So if the rate is at least 44, in this case R is greater than or equal to 44, what's your conclusion? What do you think the conclusion is about this bus?
44 is the least.
44 is the least, okay? Let's see if we can check this, because if he goes for 3 hours at that least rate of 44, is that right? And then the other one goes for 5 hours at that least rate of 44, the question is that greater than or equal to this number 352? And if you check it out, I think, what conclusion can you come to? And you say, yes, I think that this is the case. Let's put a check mark here. So therefore our conclusion is what? The question that is asked is find the least possible rate of the southbound bus. So the southbound bus, right, travels what? At least what? 44 miles per hour. Okay? at least 44 miles per hour. Any other questions? Is there another problem here that you think we should look at? Anyone have any trouble? Steve?
Number 19.
Number 19, okay. Here we have another one of these rate distance problems. We're on the same page, 174, and now this is number 19. A cargo plane left Topeka at 10 a.m. flying west at 250 miles an hour, and then at 12 noon a passenger plane left the same airport flying also west at 350 miles an hour. At what time will the passenger plane overtake the cargo plane? Again, what is the one thing that is in common to both of these planes in this problem? They both start from some point here at Topeka, and they both, well, let me decide to take the point here, and they both go in a westerly direction. Is that right? And there's one plane that starts out, and then the other plane is going to start out. It's leaving at a later time, but it's going faster, and at some place out here, the passenger plane overtakes the cargo plane. So what's the one statement that holds it all together? David says
Distance is equal.
the two distances are equal, or they are the same, okay? So what then can we say? The distance of the cargo plane must be the same as the distance of the passenger plane. Is that right? Okay? And of course, what do you know about distance? What is distance equal to? And again, Todd says,
Rate times time.
distance is equal to rate times the time. Now, let's look at the problem in which the cargo plane is traveling at what rate? And we're told, and Chuck says,
250 miles.
at 250 miles an hour. So there is his rate, 250 times. Now, what is his time? All right? And what then can we say about the time? And which the question asks, at what time will the passenger plane overtake the cargo plane? So perhaps rather than writing down this sentence first, let's decide what our variables are going to be, okay? So let's let t be what? In this case, we're looking for some number t, and Chuck says,
Time.
well, yes, t is time, and let's say that t is the number of hours for what? For the
Cargo.
well, the question asks, at what time will the passenger plane overtake the cargo plane? So let's agree, let's decide to let what? T be the number of hours for the, what do you think? And Mary Lou says, for the passenger plane, okay, for the passenger plane to overtake the cargo plane. Let me just indicate in that fashion. Well, if T is the number of hours for the passenger plane, and it leaves at 12 noon, and the cargo plane left at 10 a.m., what then is the number of hours for the cargo plane? And Jane says T plus 2. Does everybody agree with that? Okay, T plus 2 then is the number, I'll have to write that in, number of hours for the cargo plane. All right, for the cargo plane. Now, let's see what we can say. The distance that the cargo plane goes must be the same as the distance that the passenger plane goes. Is that right? So who has a sentence that we can write down here? And what do you think we can say, David?
Okay, 250 times
250 is the rate of the cargo plane times
T plus 2.
T plus 2. All right, that's his time, is equal to
350.
350, which is the rate of the passenger plane,
Times T.
times its time, which is t, okay? Does everybody agree with that sentence? Now, this sentence, to be able to write the sentence down is the most crucial thing in any of these problems. That's your model. That's your mathematical model, which you got as a result of interpreting the problem. And when you read the problems carefully, and you're looking for that one piece of information that holds it all together, and in this case, it's going to be this relationship of the distances being the same. Make a picture for yourself if you feel that that's going to be helpful, okay? Well, now that you are at this stage of the game, I think you can say, all right, I can divide both sides by some number. Don't multiply here first. Perhaps it's easier to divide. Look at 250, look at 350, and what number will divide those two numbers? Brenda says
50.
50. The biggest number there is 50, and 50 will divide 250 how many times? 50 will divide 250 how many times? 5 times t plus 2, and 50 will divide 375, what? 7t, okay? So now we use our distributive property is equal to 7t, and if we subtract 5t from both sides, is that right? We have 2t is 10, and of course t then must be, what? 5. And now let's check, And we can check by saying what? Well, t is 5, t plus 2 then must be 7. And the question is 250 times 7 equal to 350 times 5? And what do you think about that?
Yeah.
Is that a true statement? And well, without doing the work, I think you'll agree that this is correct. And therefore, our conclusion is what? The question that is asked is, at what time will the passenger plane overtake the cargo plane? So, what? The passenger plane, let me just abbreviate, plane will what? Will overtake the cargo plane, right? Let me write it up here where the cargo plane in what? In what? 5 hours. Okay? In 5 hours. And I think you will agree that we have our 5-step procedure as given in this problem. Okay? Now let's turn to the last section that we have in this chapter, in which the title of it is Recognizing Unsolvable Problems. Now that sort of gives you the clue that there might be some situations in which, you know, it isn't set up quite properly, in which perhaps there might be too much information given, or perhaps there might be not enough information given, or it might be that the answer that you end up with is an answer which doesn't have any meaning in terms of the original conditions of the problem. So let's investigate this possibility. Here's an example in which Andy has $3.75 in nickels and quarters. The number of quarters is 5 less than the number of nickels. How many nickels does he have? How many nickels does he have? X. All right. Well, let's use another variable. Let's let n. All right. Let's let n equal the number of nickels that he has. Okay. And what? The number of quarters is 5 less than the number of nickels. So how many quarters does he have? And Sally says n minus 5. Okay, is the number of quarters that he has. All right. Now, if he has n nickels, and if we think in terms of number of cents per nickel, of course we know that there are what? There are 5 cents in each nickel. How many cents are represented by n nickels? And Brenda says 5n. Does everyone agree with that? 5n is the number of cents, and that's the value of the nickels. Is that right? If he had 7 nickels, how much money is that? And everyone says 35 cents, okay? If he has n nickels, how much money does that represent? How much money does that represent? If he has n nickels, 5n, okay? And then to that, right, the value of the quarters is what? Well, how much is each quarter? 25 cents, okay? And how many quarters does he have? n minus 5. And will you agree that 25 times n minus 5 is the value associated with those number of quarters, right? So this is some number of cents plus some other number of cents must add up to what? The total number of cents, which is 375. Notice we went directly to cents. Well, let's see if we can't work with this equation. I think you'll agree that 5 will divide each of these numbers. Is that correct? So in other words, let's just look at each side here of our equation. 5 will divide 5n. How many times? 1, in which we have n plus 5 will divide 25. 5 times n minus 5, and 5 will divide 375. What? 70, how many? 73. Is that right? 75, is that right? 5 divides 37, 7 with 2, and 7 divides 25, or 5 divides 25, 5. Is that right? Okay. Well, what then do we have here? N plus 5n minus 25 is equal to 75, is that right? And 5n plus n is what? 6n, and 6n is equal to 75 plus 25, which is what? 100. And we look at that and we say n then is what? 100 over 6, but some number will divide that, which is what? What number will divide 6 and 100? 2. So we end up with what? 50 over 3. And at this stage of the game, you ask yourself the question, does this have any meaning in relation to the problem? It says, how many nickels does he have? And we ended up with what? With what? 50 over 3 nickels. And in fact, if you had to divide there, this is what? Well, 3 divides 50, what? What number do we get out of this? 16 and 2/3 nickels. and you say, uh-oh, that number has no meaning in relation to the conditions of the problem, okay? So what we can say here is the word that we can use to describe this is that the sentence, or rather our conclusion, is inconsistent. The data of the problem is such that even though it looks like a legitimate type of situation, a problem that we can solve, indeed, there's something false about the original problem, which we can call that an inconsistent situation. Okay? Let's look at another example over here, in which at a football game, the Letterman's Club sold hot dogs for 20 cents each and soft drinks for 10 cents each. All right? If they sold twice as many hot dogs as soft drinks, how many of each did they sell? All right, well, let's just start out and see where we can go with this. How many, they sold twice as many hot dogs as soft drinks. How many soft drinks did they sell? Quick. X. All right, let's write that down. Let's let X be the number of soft drinks sold, okay? How many Cokes, or rather, how many soft drinks? That's X, and how many hot dogs do they sell? 2X. And 2X. 2X is the number of hot dogs sold. Is that right? Hot dogs sold. All right, now, how much do they sell each soft drink for? And the soft drinks sold for what? 10 cents. And if they sold X number of soft drinks and each one sold for 10 cents, how many cents does that represent?
10X.
And 10X, okay? So you say, all right, there's that amount of money plus. And now what do we have? Each hot dog sold for 20 cents, and there are 2X hot dogs. How many cents does that represent? What number does that represent? David says we have what? 20 times 2X. Let's indicate that. Let's actually write that in there. 20 times 2X. And you say, well, this total amount of money plus this total amount of money has to add up to some total amount of money. So we look in the problem, and what's wrong? So he says, there's no money that it adds up to. So the only statement that we can make here is what? Well, the word the book uses is to simply say that there is not enough information, okay? One way in which the book indicates this is to say no solution. So let's say the same thing. No solution to the situation as given in this problem. Well, it perhaps rather than having us just hang in midair here, let's decide to give some number of cents to how much money they collected, okay? If they collected, suppose, let's just write down the sentence, suppose they collected, let me just make up some number of dollars. Suppose they collected $25.50, okay? All right, so you say, all right, then let's come back here. This amount of money plus this amount of money must then be equal to what? 20 times 2X, of course, is 40X, and this must add up to what? This is cents, 25.50. And in fact, I guess I rigged it well enough because what? 10X plus 40X is 50X is equal to 25.50. What? 10 will divide, 5 will divide, and hence we have X then is equal to what? 5 divides 25, 5, and 5 divides 5, 1, and X is 51. 2X then is what? 102. So it looks like, well, perhaps we had better check. Let's see now. If each hot dog, or rather each soft drink, costs 10 cents, right? Then 51 of them times 10 plus what? 102 of these times 20, and the question is, does this add up to 25.50? And let's do some arithmetic. There's 510 plus. Twice 102 is what? 204, right? And if we were to add those two numbers, we have what? 0, 4, and 1 is 5. 5 plus 0 is 5. 25.50, sure enough, is equal to 25.50, so it checks. Let's write it in over here. Therefore, if they collect that amount of money, what is our conclusion? How many of each did they sell? They sold what?
50.
They sold 51 what? Soft drinks. And what? 102 hot dogs, okay? Hot dogs. Well, let's then look at a third situation in which we have Jane handed the bank cashier $14 and asked for 3 times as many quarters as dimes and twice as many dimes as nickels. She obviously won a lot of change. Now, how many of each did she get? Okay? So, let's see now. You look at the problem again, and it asks for 3 times as many quarters as dimes and twice as many dimes as nickels. So what perhaps would be a good place to start? What would be a nice variable to pick? And Brenda says,
N is the number of nickels.
let's let n equal the number of nickels, okay? That's, I think, a good place to start. If n is the number of nickels, she asked for twice as many dimes as nickels. So how many dimes did she ask for, Steve? 2. Well, in this case, we're using the variable n is the number of what? Dimes. Is that right? And then how many quarters did she ask for? 3 times as many quarters as dimes. So how many quarters? And somebody else here, Chuck? 6n. Does everyone agree with that? It's 3 times. Let's indicate that as 3 times 2n, which is the number of quarters that she asked for. T-E-R-S, okay? Now, let's write a sentence. And who thinks that they have a sentence which is going to bring this problem together? Again, we're talking about value, all right? And if she asked for n nickels, all right? If she were to receive n nickels, and each nickel is worth 5 cents, how much money does that represent? And what can we say about this? Someone who hasn't had a chance here. Chip.
5n.
There we have 5n, that amount of money plus. All right, and each dime is worth 10 cents, and she asked, and she got 2n dimes, so that's 10 times 2n. All right, let's actually write all of that in there. 10 times 2n plus, let's then give another name to this as 6n, as Chuck said. So what, each quarter is worth 25, so let's write that as 25 times what? 6n, and this must be equal to what? 1,400, is that right? 1,400. Well, let's see what we have here. We have 5n plus 20n, and 6 times 25 is what? 150n must be 1,400, okay? And that gives us what? 150 plus 20 plus 5 is what? 175n is 1,400. And let's see now, let's do a little bit of scratch work over here. 175 into 1,400, and let's see if indeed this goes evenly. If it does not, of course, we don't have any solution here. It's inconsistent, right? Because we have to end up with an integer, positive integer. And let's see, what then can you say? Let's try what might go in there. 8. You want to try 8? 8 5s would be 40, and all right, 56. That's 60. Oh, look at that. It's 1,400. It's all rigged. N then must be equal to 8. And if n is 8, 2n must be what? 16. And 6n must be, 6 times this number must be what? 48. Let's see if we can't check, in which we have what? 8 times 5 plus 10 times 16, or perhaps let me write it as 16 times 10 plus what? 48 times 25, and the question is, does this add up to 1,400? We have here what? 40 plus 160 plus. Look, an easy way to do this is to think of this 25 as 100 times a foot. And 100 times 48 is 4,800, and a fourth of 48 is what? 12. So that's what? 1,200. Okay, so 1,200, and this is 160 plus 40 is 200, and 1,200 and 200 adds up to 1,400, and I think it checks. Okay, so therefore, she got, what's her name up there? Jane. Jane got what? 8 nickels, 16 dimes, and what? 48 quarters. Okay? Well, let me give you your assignment for next time, and I think we can go on from there. In which I think I can write it over here. Here is assignment.